This slide is going to look at the concept of buoyancy. We're looking at an object which has a volume of 2,000 cubic centimetres or 2 litres, which is going to drop into some pure water, which has a density of 1 gram per cubic centimetre. So, this water, as it's displaced, will give an upthrust of 1 kilogram for each litre, or 2 kilograms for our object, or 20 newtons of force. So we'll start off with an object that has practically no mass. The gravitational force pulling it down is approximately 0 newtons. As it drops to the water, it will sit on top of the water, as the upthrust will be equal to the downthrust at this point at approximately 0. If we increase the mass of our object to 1 kilogram, the object will now go halfway under the water. The water displaced will equal 1 litre or 1 kilogram, giving us a gravitational downward force of 10 newtons and an equal buoyant force upwards of 10 newtons. Next, if we look at this object and increase it to 2 kilograms, we now have a gravitational force of 20 newtons. This will pull the object down until it is completely submerged, giving an upthrust of 20 newtons with 2 litres of water displaced. Finally, if we increase the mass of our object to 3 kilograms, or a gravitational force of 30 newtons, the object will sink to the bottom of our tank, still displacing 2 litres and thus giving an upthrust of 20 newtons, but this isn't enough to counter the gravitational downward force of 30 newtons. In order for the object to be at rest, there must now be a reaction force of 10 newtons on the bottom of the tank. This also explains why objects which are floating in water appear to lose mass, as you can see that when you're in the bath and you feel lighter.